Now, why? So why is it considered as a circuit? Okay, this magnetic topic, why is it considered a circuit? Okay, now let me explain. Uh, so if you have an electric circuit, you also have a magnetic circuit. So what's the difference and ano, between an electric circuit, okay, electric circuit and a magnetic circuit? Okay, what's the difference between the two? They both have the word circuit. Okay, circuit, electric circuit and magnetic circuit. So is there a difference or is there a kung ano sa pangalan na ba ni sila kaparehas ng anong both silang duha na ama ng word na circuit? Okay, now electric circuit, okay, is a circuit which is made of electrons or which is made of electricity or basically electrons, while magnetic circuit is basically a circuit made of magnetic forces. So these are the two differences no, of this circuit. One is made of electrons and the other one is made of magnetic forces. So you have electric circuit and magnetic circuit. Now, for electric circuit, recall, no, you have, for electric circuit, you have three major parts. First, you have the current. Okay. First, you have the current. Second, you have the voltage. And lastly, you have the resistance. Okay. So you don't have to explain again what is current, voltage, and resistance. You already know this one. Now, if electric circuit has current, voltage, and resistance, magnetic circuit also has analogous terms. Okay. Analogous meaning almost have the same meanings, current, voltage, and resistance. Okay. Now, what will it be? First, for current. Okay. For current in magnetic circuit, okay, its analogous term is called magnetic flux. Or you can call it flux alone. Okay. Flux. In magnetic circuits, ang equivalent sa current would be flux or magnetic flux. Okay? And ang voltage, ang equivalent sa magnetic circuits is called, okay, it's called magneto-motive force. Okay? And lastly, for resistance, okay, ang equivalent sa magnetic circuits for resistance is called, okay, it's called reluctance. Okay, so current is flux, voltage is to magneto-motive force, resistance is to reluctance. Now, question is why? Why are they analogous to each other? Okay, the other three being a representative for electric circuit, and this three being a representative for magnetic circuit. Okay, now recall. Okay, you just have to recall, the current is the flow of electrons. Now, magnetic flux is basically the flow of flux. So, man ang mag-flow of flux. Basically, also din ang flux. Okay? Now, for flux, that will be our first topic. Okay? Magnetic flux, or represented by the variable phi, it is the lines of force produced by a magnet. Okay? So, for example, you have your magnet. For example, only you have a North Pole and a South Pole, of course, there will be a magnetic force coming from the North Pole going towards the South Pole. So this is what you call an attractive force. Okay? But if these two poles have the same poles, north and north or south and south, then the magnetic force produced by each one of them can be called repulsive force. Okay, so this attractive force or repulsive force These are the lines of force produced by a magnet. So it is represented by a line. Okay, so meaning the more kusgan ang magnet, the more daghan ang lines. The more hinay ang ang magnet nimo, the more sad gamay ang lines. Okay, so every force, every attraction for every attractive force or repulsive force is represented by a line. Okay, so that is magnetic flux. So basically, flux is a flow, okay, from your north pole going to the south pole. Just like with current. Current is a flow of electrons. And basically, the flow of electrons is from positive going towards the negative. Okay? So that's why they are analogous to each other. Flux for representing magnetic circuit and current representing electric circuits. Now, flux has two units. Okay? Now recall for current, yahang general na unit is in amperes. Yeah? For flux, it has two units. Namely, one is Maxwell and the other is Weber. Okay? Every one line of force, okay, can be represented by one Maxwell. And one Weber is represented by 1 times 10 to the power of 8 Maxwells. Now, why do we have two units here? Why do we have a Maxwell and a Weber? Okay, now let me explain. For magnetic circuits, there will be two main units. Okay, you have the SI unit. Okay, and you have the CGS unit. Now, what is with SI unit? What is with CGS unit? SI unit, okay, this is this international standard. So it is represented by, you have meter or kilometers, okay? Then you have kilogram, then you have second. For CGS unit, it is represented by its letters. You have C for centimeter, G for gram, and S for second. Okay, so this is the difference between SI unit and CGS unit. Again, CGS, centimeter, gram, second. For SI unit, it is meter or kilometer, kilogram, second. Okay, so SI unit and CGS unit. Now, since there are two units, you have the Maxwell and the Weber. Which one is SI and which one is CGS unit? Now, for CGS unit, okay, Maxwell belongs to CGS unit and Weber belongs to SI unit. Okay, so that's why you are given here a conversion factor, now, which is 1 times 10 to the power of 8 Maxwells is equivalent to 1 Weber. Okay, so again, Weber is in SI, Maxwell is in CGS. Now, next. Okay, no? So that is flux. What is this magnetomotive force? Okay, magnetomotive force is analogous to voltage. Sir nga naman, sir, ganun na analogous mo asang duha. Now, if you can recall, okay, I believe na if you can recall your physics, di ba, voltage has another common name, okay, or it's the original name for voltage is you have the electromotive force. Okay, so this is EMF. So magnetomotive force, MMF. Both of them are forces. This is a force representing the electron force, and this is the force representing the magnetomotive force, the magnetic force. Okay, so that's why they are analogous to each other. Now, magnetomotive force. Something ng magnetomotive force. Now, don't worry, magnetomotive force is also in the notes. You have here, no, magnetomotive force. Represented by the variable tau. Okay? So, maagirataan na. And lastly, you have ngano analogous man ang resistance ug ang reluctance. Pare-pareha sila og kuan sa pare-pareha sila og pagsulti. Okay? No, dili, no? Resistance, again, this is opposes. Okay? Resistance opposes current, flow of current, or flow of electrons. Okay? Or electrons. While reluctance, It is also the same with resistance. Nga mo oppose siya. But opposes, okay? But opposes, so naman yung spelling opposes the flow of flux. That is reluctance. Okay? So, puro sila mag-oppose. Ang resistance lang, yang i-oppose ang flow of electrons. Ang reluctance, ang yang i-oppose ang flow of flux. So, that's why they are analogous to each other. Current is to flux, voltage is to MMF, and the resistance is to reluctance. Also, don't worry, reluctance is also in the notes. You have here reluctance, represented by this variable, no? So, it's not a simple letter R lang, okay? Di man yun na ito makopy nga letter R, pero para mas madali, anaa lang, no? Na siya'y, na siya'y extra nga, so nakapag-term na siya extra nga, basta na siya extra. Okay, kaya ang resistance, ana na mga resistance, no? Pero ang reluctance na siya extra kunuhay nga. Sa may buhok, o sa ba, sa line sa buhok. Okay. Basta na ibuhok si reluctance, si resistance wala. Ano? Okay, so that is the representation, that is the representative variable for reluctance. Okay, now, balik to the rin. Again, you have two units. That is for, first, you have magnetic flux. Then you have magnetic field of flux density. Magnetic field of flux density from the word density, meaning it will be the amount of flux no on that specific area. Okay, so the magnetic flux passing through a unit cross-section. Unit cross-section is basically the same as area. If this is your certain area, how much flux is present on that specific area? So that is magnetic field of flux density. Or you can call it as magnetic field alone, or you can call it as magnetic flux density. Okay, represented by the variable beta. Beta is, of course, since you're going to determine the amount of flux present in a certain area, so that would be flux per unit area. Okay, now this is the equivalent unit for magnetic field flux density. Okay, you have also two units, Tesla and Gauss. Tesla, since density is flux per unit area, so Tesla is equivalent to Weber per square meter, and Gauss is equivalent to Maxwell per square centimeter. Okay, now which one is SI, which one is CGS? If you're going to base your decision on Weber and Maxwell, for me, I believe, mas dali mabawaan kung asay SI or CGS diha, ari ka sa area. Okay, this first one represents meter, the other one represents centimeter. And from this one alone, no, you will immediately know asay SI, asay CGS. Okay, so kung area kay meter, automatic, SI din ng Tesla. Okay, kung area kay centimeter, automatic, CGS din ng Gauss. So itong i-list down there yun. Okay, for SI unit, this is Tesla. This is Tesla. Again, Tesla has a unit of Weber per meter squared. While for CGS unit is Gauss. Okay, represented by Maxwell per centimeter squared. Okay, so take note, this is for flux. This is for flux. This is for magnetic field density. Okay, that is for magnetic field of flux density. Okay, so flux over area. Next, you have magnetic field inside of a solenoid. Unsa din ang solenoid? So, now, solenoid is basically just a coil of wire, no, wound from end to end. So as long as nakay wire yung tuyok diha, no? Okay, nya supplyan na nimo og current, then you can produce flux. So basically, this solenoid is or can be called electromagnet. Now, if you're going to, doing mo na ko skilled, basically, if you're going to make a coil of wire wound from end to end, okay, and then, okay, you're going to supply current to this coil of wire. Okay. Now, the equivalent result would be it will produce a magnetic na. It will produce magnetic flux. Okay? It will produce magnetic flux. Now, since naanam na siya yung magnetic flux, sir, so basically, magnet na dahil ni sir. Yes, magnet na ni siya. Pero specifically, it's called electromagnet. Okay, that's the specific name for this one, electromagnet. Okay, wait sa kadali guys ha. Ito guys, no? So, you basically, it can be called an electromagnet. So, electromagnet because you have formed a magnet through the use of electrons. Okay? Through the use of electricity, you have formed a magnet. Okay? So, this is basically called electromagnet. So, I believe you are familiar already with electromagnet. So, if you can recall, no, kanang mamungkag mo kanang mga dynamo. Okay? Usually, kung mamungkag mo og dynamo or dynamo, so may saktong parang. So, if we can recall, na, di mo, puro mo eh, na. So, sa dynamo, naana siya permanent magnet dere. Okay? Nya, usahay gani, itong mga mas sweet to pag yun. Ilisa na nilang mga kuan dere no, magnet dere so north na ug south ni. Ilisa ni og mga magnet itong mga mas kusgan nga magnet. So these are called permanent magnet. Okay? So these are not electromagnet. These are called permanent magnet. So permanent magnet, of course, imuhang magnetic force is permanent, di nimo ma-adjust. Okay? Kumpara nimo sa electromagnet, you can adjust your flux based on a lot of factors. Don't worry, ito nang i-explain. Okay? Now, sa dynamo, recall, mo na yung permanent magnet niya at the center, di ba, na kay gitawag dari nga core. Nya sa core, so sa imong core na anay gipangun diha nga kuan no, nga naanay gipang coil diha nga wires. Na nagito uban kusog gani kay kuan, kusog kay mo rewind og kanang mga winding sa sud sa imong dynamo kay pakusgan ginila ilang dynamo lagi kay para makusog dagan. Muhang RC mo remote control nga kuan no duaan ron sa bansiya. Okay? Now basically, this is already an electromagnet because this core with the winding will produce also with the winding will be supplied by a current, okay, and then this will produce a magnet which will oppose the permanent magnet, okay. With this opposing force, it can produce a rotary motion, okay. Now, don't worry, ma-explain po na sa inyo hang kung ano DC machines na subject, okay. Ma-explain na you don't have to worry about it. So everything will be explained, no? Doon sa may tabo nga motuyok man ang motor. So may tabo nga maka-generate mo ng voltage ang generator. You don't have to worry about it. Okay? So everything will be explained in a certain subject. Specialized na siya. Okay? So inanira no, let's say again, this is just a basic example for a dynamo. So mo na kung naka-experience mo mga inani no, namungkag mo og mga dynamo, namungkag mo sa inyong mga remote control ng mga or katong mga Tamiya sa una kung kinundo pa mo or kaabot ba ka ha? Buwangan siguro na ako. Okay? So, this, you are already familiar with electromagnet. Okay? Kung nakasuway ka ni. Okay? Now, Rita, magnetic field inside of a solenoid. Okay? What are the factors that can affect the production of magnetic flux inside your solenoid or inside your electromagnet? So, the factors would be, first, you have here mu. Mu is the permeability. Permeability of the medium where the magnetic field exists. So, ang permeability? Na basically, permeability is a constant, no? Constant na siyang permeability. Pero, okay, permeability is the ability of a material to conduct magnetic flux through it. So basically, excuse me, Permeability, ability of material to conduct magnetic flux. Sir, murag opposite lagi na sa reluctance. Recall, reluctance. Okay? Reluctance oppose the flux. Permeability conduct magnetic flux. Ay, my goodness. Pasensya na, guys. Okay? Na, opposite ni sila, si permeability o si reluctance. Si reluctance mo oppose sa flux. Si permeability mo conduct sa magnetic flux. Okay? So, nakalahi lang is, ang permeability is constant. Okay? Every material you can have a given permeability, no? And then for reluctance, you're going to solve for it. Sir, naman lagi na yung formula, sir. Okay? Now also, you can solve for permeability based on the magnetic field density and based on this H. Okay? Ang sabi ng H. H is the magnetic field strength. Okay? So this is the rough estimation of permeability. But basically, you are already, the permeability can be given already in a certain problem. Okay? So, constant na gano'n siya. Okay? So, sample, permeability of air or free space. So, that is 4 pi times 10 to the negative 7 Henry per meter. Sir, unsa man ang permeability, sir? Naasad na siya SI or CGS? Answer is yes, na-upload na siya SI or CGS. Okay? So, ano pagkaibaw, sir, nga SI na sir or CGS? Now, basic ra gyud. Ang permeability nga SI is gamay kaayo ang value. For example, kaniyo, times 10 to the negative 7. Gamay kay nga value, times 10 to the negative 3. Okay? Pero ang permeability sa CGS, dagko. For example, permeability sa CGS kay na sa 600 or na ay 3,000 or na ay 1,000. Na ano, dagko kayo. Don't worry, ako nang ihatag. Ay naata example para ano, para makita niyo ang difference. Saan niyo pag-ilang kanang permeability, kuan na siya kanang SI na siya or CGS na siya. Dali ra kay na pag-ilan, no? Then makita na rin niyo dayon sa value. Kung gamay jud kayo, SI na, kung dagko gani, okay, that is automatically CGS. Okay? So, sana sa mga factors sa amount of flux produced by your electromagnet. Again, first is the permeability. Now, permeability sa medium where the magnetic field exists. Asa man ang medium sa? Basically, ang permeability, ang medium nga gipasabot diha is at the center of your coil of wire. Okay, balik ka rin, no? Kani. For example, I'm going to put a core here. So this will be my core. Okay, it can be, my core can be iron core or it can be steel core. Okay, so na, no? Pwede rasad nga na ako gibutang nga core diha. Pwede rasad nga wa na. Okay, kung wa na mo na siya gitawag nga air core. Okay, if no core, then it is called air core. Okay, so kung wala ra kay core gibutang diha, then your permeability that you're going to use is this one. Pero kung naa kay core nga gibutang diha, either iron or steel, okay, you can, by the way, kung naa kay core diha nga iron or steel, given na ihatag na diretso ang iyahang permeability. So it's always given. You don't have to worry about it. It's always given ang permeability kung dili siya air. Pero kung air siya, you have to remember nga mo ni iyahang constant. Mo ni iyahang value sa permeability kung dili siya ay kung air lang. Okay? So dili na isulti sa problem nga kung air mo ni iyahang permeability dili. Okay? Ang lang yung ihatag kung lain siya nga material. Okay? Next. Next factor would be N. By the way, wala na ko mabutangi diha na unsa nang N. Okay? Na unsa man nang N. N is the number of turns. Okay? N is the number of turns. Saan pasabot sa number of turns? Kapila na nimo gito tuyok yung coil of wire. Okay? So, in short, from your formula here, N is at the numerator. So, in short, the greater number of turns, the greater amount of flux produced. Okay? Pero, not at all times. Ano man? So just like just like mga scenario nga naagi na yung maximum, naagi na yung minimum. Kano sa mo makaingin nga maximum, sir? Kano sa mo makaingin nga minimum? Okay? Now, this number of turns dependent na sa resistance sa imong material. Recall, kung the greater number of turns, the more taas ang imong coil of wire nga gamiton. The more taas ang imong coil of wire nga gamiton, the more sa taas ang resistance. The more magkadako ang resistance, the more magkataas ang wire. Now, take note from Ohm's law, di ba? Ohm's law is equal to V over R. The more magkadako ang resistance, the more magkamubo ang imong current. Okay? So, our second factor is current. So magbantay-bantay sad ka kay kung masobrahan sa nang imong number of turns, posible sad nga imong supply maubos. Okay ra kung imong supply pwede nimo ma-adjust. Nga imong imong say ma-keep nimo nga ma-constant gid imong current, okay ra. Okay? Kung makakita jud kag pamaagi nga ma-constant ang current, that's better. Okay? So, another factor is current. The more imong current nga imong i-supply sa imong electromagnet, the greater amount of flux could ma-produce. But there's also another effect for current. You have to watch out sa imong coil of wire. Because again, for every wire, there is a maximum amount of current na pwede parana. Okay? Recall, naara gyud na yung maximum current capacity ang mga wire. Okay, for example, there's a wire na maximum capacity niya 6 amperes lang. There are wires na yung maximum capacity 10 amperes lang. So kung mo sa pasubraan ng current, okay, paraan na nga wire, butang tag yung maximum capacity is 1 ampere lang. Imuhang gipadaka ng current kay para gyud modako ang ma-produce niyang flux. Ang resulta na sunog na hinuon imong wire kay niya na itong maximum capacity is 1 ampere. Ay imuha nang nabutangan, ay imuha nang supply is 2 amperes. Okay, usap po na sa mga bantayan. And then lastly, last factor is the length. Length of your solenoid. The length here is from the first end towards the second end. Now, kana nga end, dili ni siya kuan ha, dili ni siya kanang kung length nga kung straight imuhang wire. Okay, kani siya nga length kanang pag-coil na gid nimo. Okay, from the first coil going to the last coil. Or sample kanino, gikan diri padung diha kana nga length. Okay? Dili length nga kung straight pa ni imong wire, dili kana nga length. Okay? So the more sad taas ni siya nga length, of course, the more sad magkagamay ang imong flux. Ano naman? This is related to the resistance. Okay? So girelate na po na sa resistance ang kaning nga length. Okay, the more man magkataas ang imong resistance. So kung the more magkataas ang resistance, again, the more magkagamay ang imong flux. Okay? So nga nang magagamay man ang flux, nga resistance naman mo ni dako. Okay? Again, the more ni dako ang resistance, the more magagamay ang current. The more magagamay ang i-supply nga current, take note, current here is directly proportional to the magnetic field density. Okay? So the more saan magagamay ang current, the more saan magagamay imong magnetic field. So the more magagamay ang imong ma-produce na magnetic field or magnetic flux. Okay? So these are the factors, no? These are the factors affecting the magnetic field inside your electromagnet or inside your solenoid. Now, let's have an example. Okay, so here, let's have an example, no? A solenoid is 40 centimeters long, has a cross-sectional area of 8 centimeters squared, and is wound with 300 turns of wire that carry a current of 1.2 amperes. The relative permeability of its core is 600. Find the flux through the solenoid. Sige, let's list down one by one the given. Okay, for this example. Yan lang po. Example number 1. Example 1. First, you have a solenoid is 40 centimeters long. So you're given a length of 40 centimeters. Then you have cross-sectional area of 8 centimeters squared. So you're given an area of 8 centimeters squared. Then you have wound with 300 turns. So N is equal to 300. Then wire carry a current of 1.2 amperes. So you have a current of 1.2 amperes. The relative permeability of its core is 600. Adara. Mu is 600. O kanibe, let me ask you guys. What is this mu? Is this SI unit or is this a GS unit? Okay, answer please. Is this SI or is this a GS? Oh, guys.
Yes, sir.
CGS. Okay? Again, dali ra jud kay ninyo mailhan kung saan na siya, kung SI mo na siya or CGS. Because ang CGS dagko. Sample kanino 600 dagko. Okay? Ya, kung kuan pa ni, kung SI unit pa ni gamay kani times 10 to the negative 4 na siya. Perting gagmaya. Okay? So, again, no, dili gid mo maglisod og determine kung kana nga permeability SI ba na or CGS. Next, find the flux through the solenoid. Okay, you're just going to find the flux. Na, so may gamiton na ito nga. Kung saan man ito pag-solve sa flux. Na nakanindot aning, ano, kaning subject na magnetic circuits, kaning topic na magnetic circuits is, this is, the whole topic itself is fully dependent on formulas. Ano man, as long as you know the formula, okay, as long as there is the equivalent given, just substitute. Just like for this first example, we have to look for flux. O sige, asa may formula diha nga na ay flux. So far, these two formulas only raman ang ako ang discuss. Okay? It's very obvious. Now, this formula has flux. Okay? Flux mo ipangitaon. So, okay? But, okay? Can have flux from. Ano lang ng but? From, okay? From density equals flux over area. Okay? Okay? We can have flux is equal to density times area. Okay? Uy, na ay area sa given. Asa man tag density. Now, just have to recall. Also, you have here density is mu and I over L. Okay? So, also, magnetic density, field density is mu n times I over L. Is everything given for density? You have mu, you have n, you have I, you have L. Okay, given tanan. Okay? So, therefore, magnetic field density ni mo di ay is, by the way, diba, recall, there are two units for magnetic circuits. You have the SI and you have the CGS. Okay? Now, for this problem, kung sa may sundo na to ang CGS or ang SI. Okay? Now, for this one, it's fully dependent sa imuhang choices. Okay? Kung imuhang choices naka-SI, then convert everything into SI. Okay? Pero kung imuhang imuhang choices kay naka-CGS, then mag-CGS po ka sa imuhang units. Sir, kung mag-SI ko sir, nga kung ang mu sir kay naka-CGS man, unsa man ni pag-convert? Okay? Now, basically, there is no conversion factor for permeability. So, kung inanay mo gani nga naka-CGS imong permeability niya, you need SI. So, what you're going to do is solve first everything in CGS, then ang answer i-convert na nimo into SI. Diyan na ka mag-convert. Okay? There is no conversion factor for permeability. Okay? Just like this one. Okay? So, since everything is given in CGS, then we can solve first for CGS. Diba si GS ni ang length, si GS ang area. Okay? Ang number of turns ug ang current dili na siya dependent sa CGS or SI, no? Constant kuan ra gyud na anang given fixed na iyahang number of turns, wala na siya dependency sa imong unit. Okay? Then imong mu is CGS naman so solve first everything in CGS. So we can have here mu is 600 times you have here the number of turns 300 times the current, which is 1.2 amperes. Okay. And then lastly, divided by the length, which is 40 centimeters. So with this one, you will have density is equal to, 600 times 300 times 1.2 divided by 40. Answer is 5,400. So this is 5,400. Okay. Nung sa may unit ano eh. Since we have used CGS, or recall CGS sa magnetic flux density, that is Gauss. Okay? So this is Gauss. Or in Tesla naman na in Maxwell per centimeter square. Okay? Pero dili man density, dili man density ato ang gipangita. Ang gipangita kay ang flux man. Okay? So, diretso na, no? So, flux is equal to magnetic field density times area, which is 5,400 times ang area is 8 centimeters squared. Therefore, ang ato ang flux will be 5,400 times 8. That is 43,200. Okay, so you have 43,200. So may unit ano this is Maxwell. Okay, so recall flux for CGS is Maxwell. Muna kung gingon, no? If ang choices sa imong question kay naka SI, then from this in CGS man you just have to convert this into SI. Pero kung ang choices sa imong problem is naka CGS na, basically kani naka CGS na siya. So I want to convert to SI. So I've already given the conversion factor for the flux, no? You have here again 1 Weber is equal to 1 times 10 to the power of 8 Maxwells. So for this one, for example, if you are going to convert this, okay, if we're going to convert this into SI, so this will be 1 Weber, okay, which is equivalent to 1 times 10 to the power of 8 Maxwells. Okay, wait sa gasan. Okay, now, kung ato ning i-calculate 43,200 divided by 1 times 10 to the power of 8, that is 4.32. 4.32 times 10 to the negative 4. Or basically, we can call this as 0.432 milli Weber. Okay, so this is in SI. And this is in CGS. Okay, so again, dependent na sa imong problem. Pero sir, what if walay choices? Kung walay choices, kung unsay sa may tawag, kung unsay mas daghan nga given, or ari ka mag-agad sa imong permeability. Okay, so kung walay gibutang nga unsa man naka SI ka or naka CGS ka, ari na lang ka mag-agad sa permeability. Sample imong permeability naka CGS, CGS ka tanan. Okay? Sample imong permeability naka SI, SI ka tanan. Kaya again, ang imong permeability wala may conversion from SI to CGS. Kung sa ihatag diha fix na siya nga SI na siya or CGS na siya. So mo na kung walay gi pangutana sa problem or walay gisulti sa problem nga CGS ba nimo or SI, let's say walay choices, wherein kana nga mga pangitabo no may kana siya nga senaryo mahitabo ra na kung dili board exam kaya board exam na mo dinay choices ko. Okay? Example klase na to. Sir, what if sir nagkatag problem sa wala ka ni sulti kung unsay gamiton CGS or SI. Again, imong basihan ang permeability. Kaya again, wala man ay conversion ng permeability. So, kung sa ray unit sa imong permeability, imong sundan sa kanan. Okay? So, this is example number 1. So far, any questions for example number 1?
Done, sir.
Okay, no, so far it's very easy or it's very simple because very dependent man sa formula nga tuang magnetic circuits. As long as you know the formula, then as long as you can get the data from the problem, then directly substitute na lang. Okay? Now, next, you have magnetic field of a straight current. Or, if you have a wire, and that wire has a current flowing through it, then that wire can produce a magnetic field, which is rotating throughout the current or throughout the wire. It's rotating throughout the wire. Okay? So, in short, kana imuhang mga wire, let's say sa kanang mga outlet. So kana ding inana da sir, naa din na siya mura din na siya magnet sir, makapilit din na siya og metal. Pero ngano lagi sir nga gibutang lagi na siya tubo, wala lagi siya mapilit. Okay? Na because it's dependent on current. Okay? Because it's dependent on current. Imuhang magnetic field density will be based on or will be directly proportional to the current. In short, kung dako kayo ang current, syempre, mas dali ma-feel ang magnetic field density. Okay? Pero kung gamay kayo ang current, negligible rasad ni. Just like with kanang mga outlet nato, no? Okay? For example, ang imuhang load is ginagmay lang. So, dili ra gid na ma-feel ang murag magnet ang imuhang wire. Okay? Dili ra gid na siya ma-feel. Pero kung dinagko na, let's say, adikas poste, kaya reka sa mga transmission wires, distribution wires, dagko na kayo nag-current. Okay? So in those scenario, kana dagko na ginag-magnetic field. Okay? So solving for the magnetic field being produced by this wire with a current flowing through it, we'll have the formula mu over 2 pi times I over d or the current over the distance. Ano something distance, sir? Okay? Distance, for example, kaninga point, pila may magnetic field density diri nga point. Okay, with respect sa kaninga wire. O let's say palayan ako diri napita o kaninga distance pila may magnetic field with respect sa kaninga wire. O let's say padulaan ako gyud o kaninga distance pila may magnetic field diri napita with respect to this wire. So muna pasabo sa distance. Okay? So again, no, where d is equal to the distance from the conductor in which the magnetic field is to be determined. So note, to find the direction of the magnetic field, place the thumb of the right hand in the direction of the current and the curled fingers of that hand then point in the direction of P. So, saan man ang curl, sir? Curled fingers. Saan man na, sir? Basically, mura ra kog imuhang gigrasp ang wire. Okay, gigrasp nimo ang wire using your whole hand. Okay? Pero ang imuhang thumb, it's sticking out in parallel with the wire. Okay? So, kung unsay direction sa current, mo isundon sa imuhang thumb. Okay? Kung nasunod na nimo ang direction sa thumb, then ang kanang curl sa imuhang fingers, that is the rotation of your magnetic field. Okay? Then mag-sample tayo. Curl of fingers. Okay, nani ba? Nani siya pasabot nila. So, kung imong i-direct, no? Kung imong i-direct ang imong thumb with respect sa unsay direction sa current, then ang imong curl sa fingers mo na rotation sa imong magnetic field. Okay? So muna kung giingon nga mura ra imong gigrasp ang wire using your whole hand. But the thumb is positioned in a way nga parallel siya sa wire. Okay? So this is mo na siya right hand rule. Curl right hand rule. Okay? So, para sa ano na po daw? Curl. Okay? So, inana ra siya pag-determine sa direction sa imuhang magnetic field density. Okay? Okay, example. Ganun siya. Simple naman dito na. Again, direct sub ramang gid ning kuan. Direct sub ramang gid ning magnetic circuits. Sample number 2, a long straight conductor carries a current of 100 amperes. At what distance from the axis of the conductor is the magnetic field caused by the current in magnitude to the Earth's magnetic field about 0.5 times 10 to the negative 4 Tesla. Okay? For this one, what distance kuno from the axis? Okay. So distance mo ay gipangita kani. Okay? Nya pila kuno distance kuno gikan sa kaning axis nimo nga naka-produce kuno siya og kaning magnetic field. 0.5 times 10 to the negative 4 Tesla. Okay? So for that one, so example number 2. Given first with current na 100 amperes. Okay? Then next you have distance, again distance mo itong taon. Then magnetic field density. You are given with a magnetic field density of 0.5 times 10 to the negative 4 Tesla. Okay. So naman ito pag-solve sa distance. So recall. Okay. So naman ito, no? You have magnetic field density is mu over 2 pi times you have the current over distance. So, ang distance mo yung pangitaon, current is given, so ito na lang is ang mu. Sir, wala may given nga mu, sir. Okay? So, kung wala given nga mu, it's very obvious nga air na. Okay? Ang surrounding sa imuhang, ang nag-surround sa imuhang wire, air. Okay? Now, sa may gamito na ito nga constant sa air. Okay? Is it SI or CGS? Now, first, kung mugamit ta og SI, dapat ang ubang unit na to nga ma-relate sa SI ug CGS, dapat i-convert into SI. For example, okay? Beta, or ito ang magnetic field is in terms of Tesla. Kung sa muling Tesla, sir, kanang SI na siya or CGS? Look back, no? Tesla is Weber per square meter. Uy, SI ang Tesla. So kung SI atong Tesla, then much better we use ang permeability sa air in terms of SI. Now, by the way, karoon na to, no? Mu sa air. Okay? By the way, mu sa air, kung SI ka, katuno mo itong 4 pi times 10 to the negative 7. Pero, kung CGS ka, 1 ra. Okay? Again, kung CGS ka, 1 ra ang mu sa air. Kung SI ka, 4 pi times 10 to the negative 7. Sir, unsa mo itong 600 ganihan, sir? Kani sir, 600. Ako ulit ka na, sir. Kani kay 1 ra. Now, basically, kani siya nga 1 sa air. Na, kani siyang 600, that is another material. So, let's say that is an iron material or steel material. Basta lain na siyang material other than air. Na. Pero kung air ka, ang imuhang CGS equivalent sa permeability sa air is 1 alone. Okay? So, dali ra kayo kung air ang imuhang material kay yan naka-CGS pa gyud kay 1 ra ang yahay equivalent. So, for this one, since naaman tay magnetic field nga in terms of Tesla, is ay na lang nato tanan. Okay? So, therefore, ang ma-solve na itong nga distance will be in terms of meters. Okay? So, you will have 0.5 times 10 to the negative 4 equals mu na to is 4 pi times 10 to the negative 7 divided by 2 pi times ang current is asan to? 100 amperes. Okay? 100 amperes divided by the distance. So all we need to know is the distance. Now since nagamit man ta sa SI, so ang makuha na to nga distance this time would be in terms of meter. Okay? So solve na to ni 0.5 times 10 to the negative 4 equals you have okay. By the way, ha? Kani siya daw, no? Again, ako na nang gi-explain before nga mo kuan ni siya mo math error mas siguro to ni siya mo math error ni kung imuhang 4 by imuhang scientific notation. Okay? Para dili na siya ma-math error, mong buhaton is imuha ng bungkagon. You will make it into 4 pi. We'll make it into 4 pi niya times 1 times 10 to the negative 7. Na illegal ko ninyo para dili siya ma-math error. Okay? So you will have equals 4 pi then times 1 times 10 to the negative 7 over 2 pi then multiplied with 100 over alpha x. Shift solve. Sige. Hindi lang guys ha. Pabuton sa itong calculus. Pila iyahan ma-answer sa distance. So again, since we're using SI, everything here is in SI. Therefore, itong makuha ang unit for distance should be in meter. Okay? Okay, take note. Tesla here. Tesla is Weber per square meter. Okay, or we have already an answer which is 0.4. Distance is equal to 0.4 meter. Okay. So far, questions for example number 2. Mga pangutana sa example number 2. Wala ra yung mga pangutana sa example number 2. Wala ra. Okay, sige, let's continue na.
Syntax error.
Ha?
Syntax error ako kasi.
Error ang ako, sir.
Again, kung mo syntax error, ang kanina, inyong ginaani diretso or inyo sang gibungkag? Bungkag gasa.
Ibungkag, sir.
Oo ba? Kuan ha? Ako ara man ani ang pagkalkyo is inani ra man gyud oh. 0.5 no? 0.5 times 10 to the negative 4 ni equals okay, parenthesis nya, parenthesis na po 4 pi nya 1 times 10 to the negative 7 nya divided by 2 pi nya parenthesis na sad. Okay, then parenthesis na po 100 over alpha x. Inan na gyud ako ah. Nya shift solve dayon. Inan ra ba inyo ha? Nya mo syntax error? Tapos ba daw ninyo daw? Yeah, let me know kung nakuha na ba. Medyo dugay-dugay na ba ni sa calcio ha? Nag-shift so. Pero dili gid grabe ka dugay.
Kuha na, sir.
Nakuha na. Okay, very good. So again, nanion ra gid ninyo. Bungkaga lang gid. Kaya ang kanang pi mo makadag syntax dili mo gani syntax error, math error kanang pi basta scientific ipares na siya og scientific notation dili gyud na madawat ang calcio ana nga ang pi kay scientific notation. Okay? So kuha naman no. So ang uban practice lang gyud. Next, force experienced by a current carrying conductor. So kung naa ko no kay wire, okay? Nya kana nga wire it has a current. Again, no, of course, kana nga wire kung naa kay current makaproduce man na siya og magnetic field. Okay? But what if this wire with a current that has produced a magnetic field is being introduced to an area where there is also a magnetic field? Okay? For example, at drawingon ba? Mas dali ni siya i-explain kung drawingon. Okay? So you will have it like this. Na example mo ni ako ang wire. Okay? Then kani nga wire na ay nagtuyok diha nga magnetic field density. For example, ayaw red. Natong usbon. Yun lang. Okay? Na magnetic field density diha nga nagtuyok sa kanang nga wire. Pero what if it is subjected to a force? Okay? Okay, kung ato na siyang i-subject sa lain pod nga magnetic flux. Ang po na i-subject na to. Mahitabuan na mo counteract ang magnetic field nga na-produce sa kaning wire. So in short, posible ang mahitabuan na noon nani. Posible mahitabuan na. Okay? So kung paana siya posible mahitabuan na ang flux. Okay? Kanisa lain nga flux. Ano no, so may na mahitabo sa flux. Then since ni focus mo ng flux sa diri nga side, posible nga ma-push. This will be the reason nga ma-push paubos ang imuhang wire. Okay? So mo na siya naka-equivalent force. So mo na ni siya pasabot diri nga force. Okay? For example, kani nga wire current carrying a wire, okay? It is being subjected to an area where there is also a magnetic field. So pwede siya ma-push. Either it can be pushed up or it can be pushed down. Okay? So kana nga force, pila man nga force. Okay? It can be solved using the formula beta I n sine of theta. Now this beta is basically the magnetic field on the area nga gi-subject ang imuhang current carrying wire. Kay dili kay ang magnetic field sa imuhang wire ha, ang magnetic field on the area sa imuhang conductor. Okay? Then the current, okay, ang current sa imuhang ng wire itself. Then ang length sa imuhang conductor itself. Then sine of the angle theta. Sa man ang angle theta sa imong force because there will be times nga kani imong force, okay? Posible manggod nga kani imong force dili siya kanang straight gyud. Posible nga matakilid na siya, let's say nani no. Okay? Posible nga inana iyang force nga ma-experience in that moment. So na siya angle, so kanang angle with respect to x. Okay? So muna siya pasabot sa angle diri dapita kanang angle. Okay? So F is of course force in Newton. Magnetic field, beta is in magnetic field in terms of Tesla. Okay? Or Tesla or Gauss. Depende kung SI ba or si Gs imong gamiton. Then L is the length of wire. Okay? In meter kung SI, centimeter kung CGS. And the angle is the angle between the plane of the magnetic field density being enacted towards the wire and the current. Okay, kaning current. Now, example. Ano diretso na no? A straight conductor 100 centimeters long. Sige, number 3. Saman ko, kailan ko sa number 3. Kailan ko sa abas ba? Number 3. Number 3, straight conductor 100 centimeters long. Okay, we're given the length of 100 centimeters. Okay, carrying a direct current of 50 amperes. Current is 50 amperes. Lies perpendicular to a magnetic field of 1 Tesla. Uy, lubat ko. Okay, lies perpendicular. From the word perpendicular, it's very obvious nga ay muhang angle is ang angle theta is 90 degrees. Okay? Kay perpendicular mo kuno siya, lies perpendicular to a magnetic field of 1 Tesla. So nato yung magnetic field. No, 1 Tesla. Take note, Tesla is Weber per meter squared. Okay? Find the force experienced by the conductor. It's not a force. So recall force is beta IL sine of theta. I believe everything is given. But take note, since Tesla man ang magnetic field, yung ato ang length is in centimeters. So ang ato ang magnetic field kay in terms of SI, ato ang length is GS. So ang length na lang ako ang usbon. Okay? By the way, di ay, no? Now, since ang force na to is in terms of Newton man, therefore you don't have a choice but to use SI for everything, for the magnetic field and for the length. We're going to use SI. Okay, again, take note ang force na to is Newton man. Okay, Newton is in terms of SI na siya. Pero kung muhatag ka og force nga, foot-pound force, na English units man na. So, lahi isa na siya, no? Kung English units, wala tayo equivalent ng magnetic field nga in terms of English units. Okay? So therefore, usually, basta force ang pangitaon in terms of Newton, na. Okay? Wala tayo in terms of English units, kaya wala man tayo magnetic field nga in terms of English units. Okay? So therefore, this time, everything for this topic no should be in terms of SI. Okay? So with that, kung SI, convert ani, basically, dali raman kaya this is equivalent to 1 meter. Therefore, ang ito ang force will be 1 Tesla times ang current na 50 times ang length na 1 meter times sine of the angle 90. Okay, sine of 90 is 1. Okay, or diretso na din force is equal to 50 newtons. Okay, so far, any questions? Mga pangutana? I believe, wala rin pangutana kaya pagtirang sa'yo na no? Direct substitution ra. As long as you know lang yun, no? As long as you know lang yun sa mga given, nya asa ni mo ipang substitute, automatic. So, yun. Okay? So, inanara kadali ang magnetic circuits. Okay? Now, sige, last topic for today. Last topic for today, you have force on each current carrying conductor. Okay, force on each current carrying conductor. What if, di ba, there's a magnetic field being produced by a conductor which has a current flowing on it. But what if you have two wires? Okay, usually, na naman yung mahitabo. Sample ang ato ang mga kuan no, ang ato ang mga let's say ang ato ang mga wire sa balay. Duha man gyud na ka wires inside, dili na usa lang ka buo. Okay? So, since each of them na makaproduce og magnetic field rotating no on that wire, then there is a reaction sa imuhang between sa duha ka magnetic field. For example, okay, sa mga reaction sir. For example, let's say kaning nga wire, okay? Let's say na this wire and this wire. Okay, butang natog magnetic field ani pana. Nya kanisad is magnetic field niya is pana. Okay? So, with this rotation, as you can see, mag-abot or same direction imuhang magnetic field. So, with this one, since same man sila og direction, okay, may tabuan na, mag-combine na sila. Kung mag-combine na sila, so mo na imuhang force. Okay, mag-combine na sila. Pero what if, okay, what if, nani, mag-oppose silang duha. Okay, ang usay nani, ang usa, nana. So, inani, mag-oppose silang duha. So, ang force ana would be, nana po. Okay? So, imuhang force will be dependent sa kung unsay direction sa imuhang magnetic field. Na mahitabo na siya kung depende po sa, again, depende sa imuhang direction. Okay, recall na amantay, di ba, na amantay magnetic field. Ang ito ang direction sa magnetic field, ang rotation is based sa imuhang asa pa daw imuhang current. Di ba? So, kani mahitabo ni siya nga mag-abot mag-combine ang imuhang magnetic field kung imuhang current ana og ana. Okay? Na kani siya mahitabo ni siya nga mag-oppose ang imuhang magnetic field kung pareha sila og direction. Okay? Or ana. Okay? Sabi na no? So, mahitabo ra nga mag-combine ang imuhang mga forces or mag-combine ang imuhang mga magnetic field if ang current in each current carrying wire is opposing in direction. Pero kung parehas ang direction ng imuhang mga current sa imong duha ka wire, that is the time wherein mag against each other ang imuhang magnetic field. So in turn, mag-oppose ang force nga mahitabo sa imuhang kada wire. Okay? So this is an example. Okay? So force in each current carrying conductors. So how to determine the force? Diretso ra pod, no? You have formula mu over 2 pi times I1, I2 over the distance times the length. Now, ang distance this time will be the distance between the two conductors. And the length, ang length sa imuhang wire. Okay? And you have I1, I2 is basically the current in every conductor. Sige, example na to. Okay? Example number 4. Find the force per meter length between two conductors 5 centimeters apart carrying 1,000 and 5,000 amperes respectively. Okay, for this one. Example number 4. Simple lang. Simple 4. Find ko no the force per meter length. Force per meter length. Okay? We are given between two conductors 5 centimeters apart. You are given a distance of 5 centimeters. And then you have the currents. I1 is 1,000. And I2 is 5,000. Okay? So, pila mo ko ang force per meter. Sir, anong force per meter mo na? Sir, nga, itong formula, force raman. Sige. Ano? Recall, force is equal to mu over 2 pi times I1, I2 over the distance times the length. Okay? Kung force per meter length, okay? Again, no? Force per meter length. Basically, kana nga length, di ba? More na. Kana nga length. So, we can achieve force per meter length by dividing everything with length. So, may tabo, we will have here force per length is equal to mu over 2 pi times I1, I2 over distance. Mawagtang ang length diri sa pikas. In turn, we can arrive with force per meter length. Okay? Now, sir, unsa man nga gamiton na itong permeability ani sir? Okay, basically, wala man gisulti unsay material in between these two wires. So kung wala gisulti unsay material in between these two wires, so basically ang material ang nag-separate na sa imong duha ka wire is air. Nanara no? Kung wala gihatag, assume always nga air. Nung sa mga permeability atong gamiton sir. Is it the SI unit nga 4 pi times 10 to the negative 7 or is it the CGS unit nga 1? Okay? Now, ang deciding factor na ang force. Since ang force will be in Newton, then therefore everything here should be in SI unit. Basta na gani kay force, everything should be in SI unit. So that would be, okay? So we'll have ang force then to per meter length would be for mu. Okay, for mu you will have 4 pi times 10 to the negative 7 divided by 2 pi. Okay, times for the current you have 1,000 times I2 is 5,000 divided by the distance. We are given the distance of distance of 5 centimeters. So you convert 5 centimeters, it would be 0.05 meter. Okay, so force per meter length will be Kalkyo na to. Again ha, bungkaga ni siya. Okay. That would be 4 pi, then separate na to 1 times 10 to the negative 7 over 2 pi. Okay, then wait na. So, then next, you have 1,000 times 5,000 divided by 0.05. Answer is 20. Okay, so you have 20. So may unit niyo sir, this is 20 force per meter length man, so 20 Newton per meter. Okay, so again, very simple. All you have to do lang yun is take note sa may gamitin mo, SI or CGS. Or make sure lang mag-abot ang imuhang mga units. Mag-abot in CGS tanan or mag-abot in SI tanan. So for any questions, for example, number 4. Any questions? For example, number 4. Yeah, wala rin. Wala rin questions, guys?
Yes, sir.
Ha?
Sa kanang number 4, sir.
Hmm.
Ay, gapon na siya tanan, sir. Kay first, ang gigamit kay first man ang kuhan.
Kung sa ang kanang ay, ha?
Kanina kuhan, sir, ba kay first, puro na SI unit tanan. Dili na siya ma-GC kuhan.
Oh, puro SI unit tanan. So, muna kung giingon nga, kung nagani kay force sa imuhang formula, automatic naka-SI na tanan. Okay? Kay ang force na to is in Newton man. Wala man tay force nga in English units nga foot-pound force. Kay wala man tay mu, wala man tay permeability nga in terms of English units. So that's why basta naa na gani kay force, automatic SI na tanan. Kanirang current mo dili affected kay ang kanang current nga amperes kuha naman na kanang dili mo na siya dependent sa SI or CGS. Kaya imo harang length, kung imuhang length ug kanimuhang permeability mo lang. So magba ang pangutana. Okay, no? So, how about the others? Any questions? Okay, so, kung wala na questions, so, okay, no? So, kung wala na questions, we will continue with our discussion next meeting. So, next meeting will be our last meeting, no? That will be on Monday because next week, finals na. So, ang finals na to will be I think it's 27, 28, 29, I think. I believe so. Okay, basta next week na ito ang finals. Okay, gamay na lang, pila na lang kaadlaw, mahuman na ang second semester. Padong dayon mo summer. Okay, so muna ito ang last meeting would be on Monday na that would be on May 24. So on May 24, I'm going to discuss as far as I can go with the notes. So kung asa ta mahuman, basically diha ko to mga tuang coverage for the finals. Again, kung asa ko to ta mahuman, inig Monday diha ko to mga tuang coverage for the finals. Any questions? Mga pangutan?